Good. And I want to share my screen. This is the syllabus with the estimated schedule. Okay, so if you have time, we will continue with on the motion, but our priority today is to assign groups, lab groups. That's our priority today. The motion, Excel graphs, group assignment. Let's take this one out of here. Okay. So, but we are going to wait for more students to join us before we start assigning groups. In this meantime, let me document here. 2024. Here you go. That's where it stopped last time, right? And insert page break. Today is 09/10/25, Wednesday. It's a lab. No? Today is lab day. Lab day. What we are going to do today? Well, first thing that we're going to do, we are going to, let's see. Yeah, let's work first. Work with Excel graphs. Okay, you're going to need that. And as time goes by, more students are going to join us. And later on, we will assign you to groups. Okay, that's the plan here. As later on, right now we have 20 students only. Right, later on, we will assign you to groups. And in this meantime, later on, think who you'd like to work with. If you already know anybody else in the class, right? If you already know someone you'd like to work with, if you already know someone you'd like to work with, let's see. If you already know someone you'd like to work with, you may want to form a group with this person, right? With this person. So no more than one partner. No more than 2 students per group. 2 students per group. No more than that. So start thinking if you know anybody in the classroom that you work well with and would like to work with this person. Just you can make a group with this person. Okay. Don't take your group. Don't choose your group member lightly. Okay. Don't choose your group member lightly. Okay, and then we don't work well with everybody. Okay, don't work well with everybody. So make sure. So if you're going to choose with everybody, so comma. So if you're going to choose someone to work with you, comma, make sure you do work well. You do work well with this person. Okay. That's the plan for today. Now let's start with Excel graphs. Okay, let us start with Excel. Let's learn how to work with Excel. Let us learn how to work with Excel and how to plot graphs. Most likely, some of you already know how to do that. If you can you type there in the chat box in the chat window? Just tell me whether you have experience with Excel or not. Okay, just have experience, don't have experience, have little experience. You know, I wanna have an idea how experienced you are with Microsoft Excel. Okay, so I'm getting replies here. That's good. Good morning. No experience, a little experience, no experience, don't. Very, okay, looks like it's mixed up, right? Very little experience, little experience. Okay, no experience. Okay, so half. Let's say looks like a half and half, right? No experience, have very little experience with Excel, little barely glimpse. Okay, no experience. It's very, Excel is very easy to work with. It's not difficult. It's very intuitive, right? It's very intuitive unless you're going to do some serious programming in Excel. If you're going to do some serious programming in Excel, then it's more difficult. But just by making tables and plot graphs, it's kind of straightforward. Okay, so let me write that down here. For the simple tasks, Excel is rather intuitive. Excel is very intuitive. However, if you're going to start programming Excel, then it starts to become more difficult. More difficult. Unless you already have experience with programming, right? It's programming languages. It doesn't have to be programming languages. With other programming languages. Unless you have, but let's start 21 students. Okay, so let us start by one, making a table. No, all right, let's start. Let's see. First, open Excel in your computer, right? Open Excel in your computer. Hopefully you already have access to Excel, right? And don't forget, this class is going to be recorded, is being recorded, right? So here you go. I have my Excel here. I use this Excel spreadsheet for keep track of the attendance of my students. Okay, today is the 10th of September 25. Okay. So we want to do something that's far more than what I'm doing here in Excel. Okay, we want to plot graphs. Okay, see, I did that in Excel. See, well, last time I was doing calculations with Excel, right? I was doing calculations with Excel, and yeah, I can even plot a graph in Excel. I'm gonna plot X in the X-axis and sine of X divided by X in the Y-axis. Let's see how it looks like. Okay, let me just a quick example, right? So you go to insert, okay, insert, and then you go to charts. You have a bunch of charts here. All those charts. The one that we're going to use most of the time is this chart here, scatter. There is a scatter chart. This one is 2D column, 3D column, right? This one is tree map, sunburst. I don't even know what tree map is, okay? Sunburst. What else do we have? We can even make a 3D plot with Excel. See surface plots. You can have very nice surface plots with Excel. But what we are going to use most of the time is this one here, scatter. I scatter plot, okay? And then what I get? As x goes to 0, the ratio sine of x divided by x converges to the number 1, right? Converge. And I can even, let's see if I can do it. I want to do now a log scale here on the x-axis. Let's see if we can do it. Log scale number, axis option. Logarithmic. Yeah, I can do a logarithmic scale here. Here you go. Now we can see more clearly how the data converges to 1, right? You see that there's a bunch of data points here, right? There's a bunch of, so when we plot in logarithmic scale, we manage to see that. If you take out from the logarithmic scale, you're going to see a bunch of lines, a bunch of data points here, and you do not know how many they are. And you just do not know how many they are, right? But let's go ahead, open your Excel spreadsheet, right? You're gonna have a blank spreadsheet right in here. And we're going to plot X and Y, okay? X and Y. That's going to be your proxy for future graphs, okay? And I'm going to do the simplest of all plots that we have out there. I'm going to do the simplest of all plots. It's going to be the linear plot, x equal to y. Sorry, y equal to x. Better this way, right? Y equal to x. Y equal to x is going to be, if x is 1, y is going to be 1, 2, right? 2, y is going to be 2. 3, y is going to be 3. 4, y is going to be 4. 5, 5. I usually like to have 6 data points in my graphs. That's what I like. In order to plot a straight line, all you need is 2 data points. But I prefer to have like six data points. The more data points you have, the better. Okay, and that's gonna. You already know what the graph is gonna look like, right, folks? You already know how this graph is gonna look like from your math classes. Everybody has. So I want to give an opportunity for you folks to open Excel, right? Have you been able to open your Excel? Hopefully, I'm not going too fast. Want to hear from you folks? Have been able to open your spreadsheet?
Yes, I was able to.
Okay, good. So you have who is having any problems opening a spreadsheet or even installing, right? Having access to a. If you have problems accessing Excel, let me know, okay? So, but it looks like many of you have the spreadsheet there, okay? And now we are going to plot this simple graph. Like I said, you already know what this graph should look like. Is y equal to x. Y equal to x is supposed to be a graph with a straight line that passes through the origin of the xy axis and has an angle, the line has an angle of 45 degrees. Okay, so here you go. Insert, chart, scatter. Like I said, we're going to use a scatter. I prefer, never, throughout the course, do not choose those graphs here. Do not choose those with lines depicted, okay? Choose the one without the lines connecting the data points. Just the data points, just the raw data points, okay? Here you go. I don't like to have this Y here at the top, okay? So I usually erase it. I click on that Y and I erase it. And what else do you have to do? Right? Oh, you gotta spice up this graph. You gotta put some nice labels to the axis, right? You gotta put a label for the y-axis. You gotta put a label for the x-axis. So far, you do not have any labels whatsoever. So how do you do that? In order to have a label for this graph, first you have to click the graph and watch what happened here at the top. Okay? Watch what happened here when I click the graph, and when I click the graph, look here, two more options shows up. Not only those two options show up, but the table that I plotted my graph is highlighted. See that? And I can even move this square. If I move the square to the right, I'm not going to have any data points whatsoever because I'm selecting a region with no data points, right? If I move it back to Y, my graph is returned back. Okay? So let's unclick again. And now I'm going to put the labels to the axis. Click the graph again. You need to click the graph to put a label to your axis. And look for chart design, okay? There are two options here, format of the chart and chart design. And in the extreme left, you're going to see add chart element. This chart has several different types of elements. And, you have elements for the axis, you have elements for the axis title, chart title that goes above the chart, the one that I deleted, remember? Center overlay, let's see what center, okay, center overlay is like that, but I don't want any chart title. Data labels, none. We're not going to use any data labels in the label, but if you need, let's see, if you need to use data labels, center left, oh yeah, here you go. Yeah, center doesn't show anything, right? But when you go to the left, okay, that's what I mean by data labels. Data labels are the numeric value of those data points, okay? But we're not going to use that either. I don't like to use the data labels. Left, right, above, below, see that? Data call out. Okay, data call out means what? The X and Y values, right? But we don't use that in physics. We just, for data labels, we just choose none. There is also error bars, grid line, legend, trend line, okay? What we're going to do here, what we want here, we want the axis title. You have the primary horizontal, right? And then see the primary horizontal. Now you can write down the name of the title of your axis. And then you have the primary vertical, okay? The name of the primary horizontal axis is the x-axis, the one that I labeled right here. For the primary vertical is the y-axis. Okay, for the label here. So we are going to be doing that every time in physics, in the lab. Okay. And what else do you have to do? Now comes the important part. We are going to plot, we are going to find the equation that best approach these data points. We're going to find the equation that best approach these data points. That's what we call the trend line. In order to get the trend line, you click in one of the data points. Okay. After clicking, you have to right-click your mouse and then look for add trend line. Look for add trend line. Okay. As we progress through the course, I'm going to show you how we are going to use the other ones. But for now, this is the most important one, trend line. Select trend line and look for this pane here on the right side. Okay. See that this pane can approximate your data points, can write your data points in terms of different functions. can write that in terms of exponential function, logarithmic function, polynomial, but the default is linear. The default is linear because most processes in physics are linear. In engineering and physics, not just physics, but engineering as well. Okay, so it's already checked that for you. And now you have this line, right? This dashed line detected right in here. That's why I don't want you, remember? That's why I didn't want you to plot this graph with those lines, because we are going to get the exact, the most important line. The most important line is the trend line that's calculated for this data point. There is more that we need to do. There is more linear. Now go there at the bottom, look at those options here. Set intercept, display equation on chart, and display R-square on chart. I never use set intercept. I never use it, okay? I don't like to set the intercept of my graph. But you're going to need to check the display equation on chart. See how smart Excel is? Excel allows you to, Excel is smart enough to tell you what's the equation of this set of data points, okay? And there is one more thing that you have to do. Remember, you're not gonna set the intercept, but you're going to check the display R-square value on chart. I'm gonna tell you about R-square. I'm gonna tell you about this value R-square, which is a statistical parameter, very important in experiments. Am I going too fast? Let's see, someone left a message for me. May you repeat that, Professor? Let's see. What, 10:02? Okay, so here you go. Let's do it again. I'm gonna do that again. Okay, Melissa? I'm gonna erase my trend line. I'm gonna erase this trend line as well. Up to here, you folks have been able to plot, right? I want to hear from you. Have you been able to plot up to here?
Yes.
Okay, good. So what do we do next? You're going to get the trend line for this set of data points. Click one of the data points. When you click on the data points, all data points are highlighted, right? Right click on the data point, and then what do we do? Add trend line. There are other ways to get here too, okay? But this is just one of the possible ways of getting to the trend line. It's just one of the possible ways. Okay, when I click highlight add trend line, this pane on the right side is shown. It may vary from computer to computer, right? Especially the Mac. The Mac has a different display. And the linear option is already checked. Linear option is already checked. And here we have an approximation of the equation of a linear equation to those set of data points. In this case, it's not an approximation because we know that it's exactly y equal to x. Okay, but in experiments, we can get straight linear equations that are an approximation of the data point, and we are going to see that very soon. And what you're going to do next, you're going to display equation chart. Okay? Display equation chart. And the equation here is displayed. Every physics lab, you have to do that. And on the top of that, you're going to display the R-square value on chart as well. Okay? The procedure, right, that I did right now is spelled out in your syllabus. It's spelled out in your syllabus. Let's take a look. The syllabus. Right in here. Let's see. Graphs, if any. Graph must be clean and planned to optimize the space, right? No large, keep that in mind, no large blank areas in the graph. I will determine the grade of your graph with respect to the percentage of the area in your plot. For instance, if you use 10% of the total area of your graph, you get only 10% of the points, okay? You must label the axes of the graph with their proper quantities like we did and their corresponding units. Right now, I'm not using a units for that graph. For each missing incorrect label or unit, I will subtract 1 to 2 points from your report. In other words, if you miss all labels, 2, and units, 2, I will subtract 4 to 8 points, right? 8 points from your report. Ensure the numbers along the axis are properly spaced. Do not connect each data point with straight lines. Instead, fit the best average curve to this data. This can be done in Microsoft Excel by clicking on one of the data points in the graph. When you do that, all the data points in the graph are highlighted. Okay, again, this is in my syllabus, page number 4. Right-clicking on one of the data points in the drop-down menu, highlight Add Trend Line option. Select one of the trend lines, regression type. Most of the time, you use the linear trend. Checking the boxes. Check the box by checking the box to display the regression equation and the R square in the graph. Do not check the box set the intercept equal. And then you click OK. That's what we did. Okay. And now let's talk about what R square is all about. What R square is all about. No questions, right? Everybody's doing well there.
I have a quick question, Professor.
Go ahead.
So, like, for this graph that we did right now, if like we turn something in, would this be considered like full credit? Like we plotted it correctly? Like this is what ideally you would like us to set it up like?
Yeah, when you
Obviously the
do.
numbers will be different and stuff and like the
Oh yeah,
all of
yeah.
the
The numbers will be different. What we are doing right now is just a sample for you to learn how to plot graphs. Okay,
Okay.
you don't
Okay.
have to turn this graph on. But later on in the lab that we are going to do, you're going to be using different data sets, and then you have to do everything that I did here. Get the trend line, get the R square, right? Label the X and Y axis. Okay.
Yeah, so like but this is an example, like let's say this was like our lab report and we plotted this, this is what we would get full credit for. Like this is how it's supposed to look in terms
Yeah,
of all the things we included. Okay.
that's right. You can see that you can see from this graph that you have very little blank space here, right? And I cannot do better than that. If you
Yeah.
plot your graph, if you had this data set and you plot this data set in this way, you'd get 100% of the points of this graph because you have a very small area here that's just blank. Because what happens, right, in real life? What happens? Many students, when they plot their graphs, what do? They do the following. I'm going to give you an example, okay? I'm going to give you an example. Instead of going from 0 to 7, sometimes they put it from 0 to 20. And this graph doesn't look good, right? You understand? Many students do that. And here, look at the huge blank space that you left where we have no data points. If you give me something like that, I'm going to take out points because of this huge blank space that's in the graph, okay?
Okay, that makes sense. Thank you so much.
Okay. And Excel does not always optimize the space of your graph, okay? Excel does not always do that. You have to look at the graph and work on it, okay? Okay, so now let's take a look at R square, right? This equation here, there is a mathematical technique to calculate this equation. There is a mathematical technique. Let me put that here. There is a name, the name of the mathematical technique is a really smart mathematical technique. Opening Excel in your computer. Opening Excel in your computer. Here you go. Type a table with X and Y values, right? 3, plot a graph. 4, adding the trend line equation. 5 adding the R square value, inserting the labels of the axis. Okay, that's what we did so far. Now, what is the R square value? Okay, this R square value has a name. In statistics. It's called the determination coefficient. Determination coefficient. Can you remember that? Very important. And the value, and the R value, not the R square value, but the R value, which is the square root of the R square value, right? And the R value, which is the square root, square root of the determination coefficient, comma, is called the correlation coefficient. Okay. For some reason, Excel was programmed to display the R square value. I don't know why. I don't know why. If I were them, I would be displaying the. Oh, actually, there's a reason. There's a reason for that. Yeah, there's a reason for that. But I'm not going to tell you. Okay. There's a good mathematical reason for that. Okay. And I prefer that Microsoft to Excel display the R square value. I prefer that. Now, what is the mathematical interpretation of these two coefficients, right? Of these two parameters. What do they tell you? Okay. First, the correlation coefficient, R, has a range, has a value between -1 and +1. Okay? That's the numerical value of the R, of the determination of the correlation coefficient. Can be anywhere. I should put an equal here. Let's see if I can get that. Insert greater or equal than -1, right? Here you go. -1 greater or equal at less or equal than +1. Those are the values. And what these numerical values mean? What these numerical values mean? Or if the correlation coefficient has a value between -1 and 1, the determination coefficient, R square, is going to have a value. Remember, the square, right? The square of negative number is a positive number. Will have a value between 0 and 1, right? Okay, so what does it mean? You know, the closer R square is to 1, okay, the closer your data points will be to your equation, to your trend line equation. Let's put it this way. Trend line equation. Okay. R square equal, what does it mean? R equal. r squared equal to 1, r squared equal to 1 means that the trend line equation has a perfect correlation with the data points. Okay, 100% correlation, has a 100% correlation with the data. That's what it means. And that was exactly what we got in that plot. See that? We got an r squared equal to 1. We're getting an r squared equal to 1 because what you have here is fits exactly a linear equation. Okay? Fits exactly a linear equation. In real life, I'm gonna write that down here for you too. In real life, you hardly got, in real life, you hardly get an r squared equal to 1. If you get an r squared equal to 1, there is, let's put another here, point here. If you get an r squared equal to 1, if you get an r squared equal to 1, no? That will be because of the following reasons. Will be because of the following reasons. 1, either you made a mistake. B, either you cheated in your data points, or most likely, that's because, or you need to use better instrumentation to collect your data. Okay, to collect your data. For instance, use a ruler with 1 millimeter resolution instead of a ruler with 1 centimeter resolution. Have you thought about that? Or let's put or here instead, okay? I have seen something like that happening in one of my experiments. And that happened. We got an r squared equal to 1 because we were using a ruler that didn't have much of a resolution. Like it was not a ruler with a 1 millimeter resolution, right? With a spacing, with a smallest spacing between in the ruler. But it was a ruler that was 1 centimeter spacing. The smallest division of the ruler was 1 centimeter instead of 1 millimeter. Okay. So keep that in mind. In real life, you hardly get, as said before, in real life, you hardly get an r squared equal to 1. But in most of our experiments, your r squared will be very close to 1. Let's say it's going to be like 0.0998, right? or 0.95 or whatever, right? 0.98 and so on. And so on. Okay, so that's the interpretation for the R-square. It's how closer your data points is to your trend line equation. And R-square equal to 1 means the trend line equation has a 1% correlation with the data points. The second equation, 1009. Second equation, which second equation, Gabriela? I'm a little bit late here, sorry, in answering your question. I just saw your question, Gabriela. The R-squared equation. But which equation? This one? Are you talking about this one here? Which one? You're talking about the trend line, right? You're talking about the trend line equation. That's what you mean, right? Means that the trend line equation has a 100% selected points. Here you go. The equation I'm talking about is this one here at the top. See that? The trend line equation. That's the one I'm talking about. Okay, that's the equation I'm referring to, the trend line equation. Lots of definitions, right? So many definitions that we don't memorize them the first time. Okay. Now we're gonna play, with those numbers that you have right in here. And you're going to see what's going to happen to the R-square, okay? So here you go, let's write that down here. Now, we are going to play with the numbers in our table and see what happens to the R-square value and the trend line equation, okay? We can do that. We can play with those numbers so you can have a good idea of how this whole thing works. Instead of 1 here, I'm going to put 1.1, okay? See what happened to the equation? The equation is still very close to y equal to x, very close, right? But it's not exactly. And then what happened to my R-square? My R-square now is slightly below 1. See that? This is, this table that you see right in here is more realistic than the previous table that we had before. From the real world viewpoint, whenever you're performing an experiment, you're more likely to get a table like that than to get a table like that, okay? And then we can keep on playing with it, right? So let's see, instead of 2 here, I'm gonna put 2.2, okay? And let's see what happens to my numbers. Okay, we deviated even more from the y equal to x equation, right? Before we had what? The slope was what? 0.98. Now the slope is 0.96, 0.97. Before, the R-square was 0.9997. But now, because the number is deviating from the ideal equation, the R-square is going to be a little bit less, right? 9997 to 9989, okay? See what's happening? That's the type of data that you should be getting. And let's put 2.9 here now, right? It's a little bit off the ideal equation, but that's how real life works. He's gonna put 3.8, It's gonna deviate a lot. Look at how my equation changes as those data points, okay, deviate from the average line. Here you go. Okay. Are you getting an idea what this R square means, right? And also the trend line equation. Now, sometimes it may happen, right? Sometimes those things happen in real life too. Sometimes you get what we call outlier. Sometimes you get an outlier, okay? And an outlier looks just like that. This guy here is an outlier compared to everybody else. Okay, is way off. Sometimes we do get this type of data points. Okay, and those outliers, they usually affect a lot your equation. They do affect a lot your equation, and I'm going to show you. When we have an outlier like that, it's usually it's very, how do you say, advisable to exclude the outlier from the plot, because the outlier is so far away from the other remaining data points that is skewing completely your final result. And so how do we exclude? You're gonna plot only the other 5 points, and I can do that in Excel. See, I'm excluding that point in which y equal to 10. Okay? And now we have only 5 data points. Let's look what the difference is. Look here, 0.96, right, for the slope, right? With the outlier, the slope is much larger. Is what? Do you remember how much was this? Oops. What was the slope before? It was 1.5, right? See? Here you go. Here you go. Was 1.54. If we exclude the outlier, now we don't have 1.54. We have 0.96. Okay? And the R square is 0.9901. Let's see what was the R square with the outlier. 0.99, remember. 0.99, which was 0.83. Okay? So we do have, every now and then we get something like that, okay? Not all the time, but every now and then. Sometimes it's just equipment that failed to collect a proper point. Sometimes a mistake of the student when they collect the data, they mistype it, for instance, the value, numerical value. That's what outliers are all about. Or something extraordinary happened while you were performing the experiment that was completely outside your control. That happens too. Okay. So let's go back to the other one you had. Outliers. Okay. So what we did here, we started changing the values of y slightly, right? To see what happens to the trend line equation and the R square value. And by the way, there is an equation for the R square, okay? You don't have to memorize that, but it's good to know that there is an equation for it. Equation for the determination coefficient. For the determination coefficient, let's see here. The equation for the determination coefficient, the equation for the coefficient of determination can be expressed as the square of the correlation coefficient. Yeah, good. And what's the equation for the correlation coefficient, right? Okay, so let's get the equation for the correlation. Equation for the correlation coefficient. Not very useful. Okay, here you go. Here's the equation for the correlation coefficient. Here's the equation for the correlation coefficient. I'm going to write that down for you. Okay, I'm going to put aside and copy this equation. And yeah. Okay, so here you go. R, the equation for the correlation coefficient is some books display the correlation coefficient as a lowercase r, but for some reason Excel just like to display it as a uppercase r. Okay, so let's use Excel's notation. And I'm going to, here you go, r equal to, don't forget, n is the number of data points. In our case, n in this case is equal to 6. X sub I is the data point. Y sub I, and there is one more thing here that I'm missing here, was that is the summation sign. Summation sign, here you go. I going from 1 to n. Let's cut and paste here. Excel does all this math for you. Okay, and what else? We have another term. We don't need this parentheses. I do not know why they put this parentheses here. You know, the summation sign already has the implicit assumption that what we need a parenthesis here. Okay, we need a parenthesis here, not on the outside. And I'm gonna have another summation minus xi yi. And okay, and then we have to divide this whole thing by a square root. We're going to have an n downstairs, but instead of xi, it's going to be xi squared. Yeah. And I'm going to have another summation. It's going to be something like that. Actually, it's going to be a negative sign. And this one is going, oops, it has to be inside the square root. And they're going to be raised to the square. Oops, the square went to the wrong place. Okay, here you go. There are more. And we have a parenthesis here because we're going to end up multiplying another term. Don't forget, right? The Excel is doing all the math for you, right? You don't have to do this whole thing. During my time, we had to do that, believe me. And so here you go, it's going to be y squared, yi squared, and yi, summation of the yi square, right? Here's the square of the summation. Here's the summation of the square. It's different. That is the equation for the R square. And there is also for the equation, for the trend line equation, we use the method of the least squares. Okay, there is a method called the method of the least squares, in which you minimize the difference, you minimize the difference of the squares. That's why it's called method of the least squares. And then there is an equation for the coefficients that go in front of the x and the slope, right? And it is possible, and using this method, here go, and using this method, it's possible to determine the slope and intercept of the trend line equation. Okay. 1038. Going back. So that's the whole thing about plotting graphs. Okay. Let's see if there is more. I have more here. It's all of that stuff is all in my notes of the last year when I taught this thing before. Okay. Okay, so summary. One, trend line equation. And R square value, right? We covered summary. We covered the following concepts. The trend line equation, which most of the time is going to be a linear equation, which most of the time is going to be a linear equation. And R square value, which most of the time will be a number close to 1. Okay? Then 40. Hopefully you're not getting burned out. Let me take attendance. Lab, let's see how many students we have. We have 24 students right now. Did you group number? Right now we're going to choose the group number. I'm gonna take a roll, and I'm gonna ask you if you have a group partner to be with you in the group, work with you in the group, okay? So let's see, is Sinue there? Sinue Abundes? I don't see Sinue, okay, it's not coming. 0, right? Eric Alcala, are you there?
Here.
Okay, do you have a student that you'd like to make a group
No.
with? Yes? No? Okay. Okay, so I'm for now I'm just gonna choose the next student that goes here in alphabetical order, okay? If later on, if you want to change your group, let me know. Okay, let's Edith, do you have anybody, did you already choose anybody to be with a group with you?
Not yet.
Not yet? Okay, so you don't, okay, so I'm gonna put you with Eric, okay? You can exchange your contact information with Eric. I'll put you in group number 1. And then let me write that down here. First, Okay, now I will choose, we will organize you in groups, okay? After that, I will provide you with a link to your group folder, okay? This this link, do not share this link with anyone outside your group. Okay. After that, I'll provide you a link to your group folder. Do not share this link. And by the way, this link is located in my Google Drive. Google Drive, okay? In my Google Drive. You know, it works very well with Google Drive. Last semester, I tried to use Canvas to do that. It was such a big problem. You know, I was having all sorts of problems. You know, let's put just a little note here. Last semester, I was using Canvas, right? Instead of my Google Drive. And unfortunately, it didn't work well. It did not work well. For this reason, I returned. For this reason, I returned. I went back using my Google Drive. Okay, so let's go next one. And Jawaira Ali, are you there?
Yeah, hi.
Hi, okay, so let's see. Group number 2, okay, Jawaira?
Yeah.
Okay, group number 2. Evelyn, do you know anybody else that you'd like to be in your group? Jawaira?
Arva, she's all the way at the bottom.
Type in the chat box. Type that in the chat box for me. Please.
Okay, hold on.
Let's see. Awa, Arwa. Let's see. What's the last name of Arawa? Arwa, right? Let's see here if I can. Paris. Okay. Paris. Okay, good. So, Arwa, are you there?
Yes.
Okay, so you're in group 2, right?
Okay.
Arawa, Paris. Group 2, you are there. You're in group 2 with Jawaidia. Good. So next, Evelyn. Is Evelyn there? I don't see Evelyn Ayala. Whoever is not present for now is going to be on group 0. Okay, Ben Bendoy.
Yeah, I'm here.
Okay, do you already have someone to join your group?
No, not yet.
Not yet. Okay, so just like I did with Eric, I'm gonna get Melissa to. Let's see if Melissa is here. Melissa is here, right?
Yeah, I'm
If
here.
Melissa has someone else, right?
Hello.
Okay. Do you have Melissa? You're there, right?
Yeah.
Okay. Do you have anybody that you would like to be in your group?
No, I do not.
Okay. So I'll put you together with Ben, and you can exchange information, contact information. Okay.
Okay.
And let's go for Miasia. Miasia Bragg. No, it's not here. Madeline Brock.
Here.
Okay. I'm gonna put you in group 4. Do you already have anybody else that you'd like to be in your group, Madeline?
No.
No? Okay. So I'm gonna, let's see if Cynthia, right? So the next student here in the list is going to be in your group. Okay, so let's see if Cynthia is here. Cynthia Candelario. I don't see Cynthia Candelario. Next is going to be Queen Castaneda.
Professor, she said she was having issues with her laptop, so I think she left the meeting, but we had agreed to be in a group together.
Okay, you are talking about Cynthia?
No, for Quinn.
Okay, and who is that? Who is talking?
Emily Serna.
Emily? Okay, Emily Serna. Okay. So I'm gonna put Queen and Emily in group 5, right?
Yes, thank you.
Okay, Emily. Emily, let's see. Okay, so group 5. Okay, Queen is not here, but you're going to be sharing the group with her. Queen. So let's see. Madeline. Cecilia, are you there, Cecilia? Cecilia is not here, right? Cecilia Chavez is not here. Next, Isabella, are you there? Isabella Cisneros. I don't see Isabella either. Next, Jacob Contreras. I don't see Jacob either. Next, Delisha.
Yeah, I'm here.
Okay, your group. Okay, well, what about joining Madeline? Unless you have someone else that you have chosen. Do you have anybody else that would like to be in the group with you?
No, I can join with Madeline.
Okay, good. So exchange contact information, right? Just Madeline. And let's go, Gabriela.
I'm here.
Okay, Gabriela, you're going to be group number 6. Do you know anyone that would like to be in your group, Gabriela?
No, I don't.
You don't. Okay, so let's see if Angelica. Is Angelica here? Yes, looks like she's here.
Yes.
Do you?
I want to work with Princess Gate.
Okay, Prince. Okay, so it's gonna be group 7. Princess. Let's see where Princess is. Okay.
I'm here. She's right below me.
Okay, just below you. Okay, good. And Princess is here, right, Princess?
Yes, I am here.
Okay, thank you. Carlo Gallardo.
I'm here.
Okay, do you have anybody that would like to be in
No, I
your
don't have
group?
anybody.
You don't? Okay,
No.
so I'm gonna put you with Gabriela. Okay.
All right.
You can exchange contact information, and you'll be working together. And Brandon Guerrero, is he here? Yeah.
Yeah.
Do you have anyone that would like to be in your group, Brandon?
Nope.
Okay, you're gonna be group 8, and you are here. Let's see, Arturo. Arturo is here. No, Arturo Lagunas is not here. Next is Janie Maldonado.
Hi, I'm here. I don't have
Okay,
anyone that want to be in a group though.
okay. Okay, so we'd like to join with Brandon.
Yeah, that's fine.
Okay, so exchange contact information with Brandon. Okay, and I believe you can reach anybody in the class using the Canvas email, right? I believe it's possible to do that. So
Professor, can you enable chat so we can send like
you
chat
mean
to the group?
chat in Zoom?
Like starting a new one? Like if we want to message the person that you just assigned us with?
I know, but you want me to do that in Zoom, right?
Yes, please.
Okay, so how do I do that? The Zoom changes things, Let me see, new chat. How do I do that? Let's see. Do you know how to enable that?
Yeah, you can click on the three
Three
dots
dots.
and you can enable chat for
So,
other parties.
I click the 3 dots here, and it shows participants can chat with everyone. So it looks like it's already enabled.
It says this host has disabled group chats, but okay.
It's there. Let's see here. By the way, if you guys okay. Can you contact the other students through chat?
Not through Zoom, but we can do it through Canvas.
Yeah. Okay. Yeah, because from what I see here, it's already enabled unless there's something else that I have to do. You know. Is that maybe I should do new chat? Is that how it works? Yeah.
Yeah, you should be able to chat with individuals, but it just looks like it's disabled on your end.
Uh-huh. Yeah, but it says here that it's enabled. See that? It would be
Okay.
disabled if host and co-host only. See that? Now it's disabled. Now if I put participant can chat with everyone, right? Now check again. See if you can chat with the other students.
No, you can't click on any other student's name.
Uh,
It's okay.
yeah, I do not know. It looks like there's a bug here in Zoom. Okay, so good. So let's go Isabel Medina, right? Isabel Medina is here. No, Isabel Medina is not here. Stephen? Stephen is not here either. Next is Kimberly Morales.
Present.
Okay, so you're going to be in group 9. Okay, Kimberly. Do you know anyone that would you like to be in your group?
No, I don't have anyone.
Okay, so let's see if Montserrat.
I'm here.
Okay, do you have anyone in your group already? Do you would like to be in your group, Montserrat?
I don't have anyone to be a group with.
Okay, would you like to join Kimberly in the group?
Yeah, I'm fine with that.
Okay, good. So let's go for Corina now. Corina Paez. Let's see if Corina is here. Doesn't look like she's here. Corina, 0. Catherine Perez. No. Next, Nicolas Rivera.
Yeah, I'm here.
Okay, so you're gonna be group number 10. And Nicholas, do you have anyone that you'd like to be with you in the group?
No, I don't.
Okay, so let's see if Elizabeth Saldana, are you there? No, Elizabeth's not here. Jason Cervellon.
Here?
Okay, do you have anyone that you'd like to be, do you know anyone that would like to be in the group with you, Jason?
No, I don't have anyone in a group.
Okay, so we'd like to join with group number 10 with Nicholas Rivera.
Okay, sure. Yes,
Okay.
thank you.
Exchange contact information. Armand, let's see, okay, Armand is here, right, Armand?
Hello?
Yeah, I can hear you. Group 11. Do you know anyone that you'd like to be in the group with?
Doesn't matter.
Okay. Yeah, yes or no?
I'm sorry, you'd like to say it again? What was the question?
Do you know anyone that you'd
No.
like to be in the group with? Okay,
No, I
so
don't.
let's see, Jenya. Okay, so I'll get someone to join your group. Jenya Tapia. I don't see Jenya is here. Okay, 0. Juan Torres Arellano. I don't see Juan either.
Oh, I'm here.
Oh, Juan is here. Okay, good. Juan Torres. Okay, do you know anyone that you'd like to be in the group with, Juan?
No.
No? Okay, so I'm gonna put you with Armon, okay?
Okay.
Okay. Marian Ziwaldin. Marian, I don't see Marian here. Okay, Sydney Hill.
I'm here.
Okay, do you know anyone that you'd like to be in the group with, Sydney?
No.
Okay, so I'm gonna do the following. I'm going to put you in group 11. Okay, it's gonna be
Okay.
it's going to be like a exception because we don't have any more students. So get in touch with Armand and Juan. Okay, and you'll
Yeah.
be able to work together. Okay, so 10:57. Let's see how many students we have here. 21. Okay, looks like we have 22 students. Who was not called, by the way? Oh, no. Here you go. We have 22. Good. Everybody was called. It's just my equation here that didn't. Yeah, 31. Good. Now we can have our break. And we're done with groups. We're done with the groups. And next, I will provide you with a link to your group folder. Okay. Do we have time to do that? I don't think we don't have time. Let's have a break right now. 10:58 a.m. to 11:13 a.m. Okay. So let's have our break right now, and I see you in 15 minutes. All share, stop share. I'm back here, and I will now distribute the links, okay, for your group folder. So I'm going to get this group one. Let's see, group one. Let me organize the links here first, and I will email them to you. Let's make sure that the links are correct here. Yeah, that looks like correct. 5. Okay. I will send those group links through the chat. And let's see, let's start with group one. Group Group 1, Eric and Edith, right? Eric Alcada. Group 1, Eric and Edith. Let's get Edith here. Edith, okay. That's your link for group 1, Eric and Edith. Let's make sure it works. Let's see. Yeah, it's working well. Let's go for group number 2 now. Lord. Group number. Group number 2 now. Jawaria and Arwa. Group 2, okay, the link is working. Here's your link. Wow. Okay, Arwa Paris. Here's the link. Go ahead, click in your link. Make sure you are getting to the right link, okay? For those groups who got the link, right? Here you go. Suppose you are group number 2. Once you click the link, you should see group number 2 right in here, okay? Oh, I'm gonna share the screen. Let me share the screen. Here you go. Here you go. Once you click the link, you should see your group number here at the top. That would be for group number 2. For group number 1, go ahead and make sure that you have your group number documented here at the top, right? And the same apply to the other groups, group number 3, 4, 5, okay, and so on. Now let's go. Let me stop sharing here. Let's go for group number 3 now. Group number 3, Ben and Melissa. Ben and Melissa.
Sorry, Professor, your video froze on my end. Can you show again where we should find the groups when you
Sure.
post it?
Which group number are you?
Group 4.
Group 4. Okay, let me send you the link for group 4 first, and I'll do it again, okay?
Okay, thank you.
Group number 4, Madeline and Delisha. Madeline. Looks like Madeline is no longer. Madeline. Yeah, it looks like Madeline is no longer here, right? Delisha. Group number 4. We'll just click. Yeah, you just click the link, Melissa. Melissa, just click the link. Let me click the link here. Okay, yeah, it does work. Group number 4. So share this link. It doesn't look like Madeline is here. Okay, Delisha. So you can share this link with Madeline. So click the link, see if you are, and let me show you again. Once you click the link, you are supposed to see, okay, in the case of group number 4, you are supposed to see this screen here with group number 4 at the top, file folder group 04. Okay, once you click the link, you're supposed to see this.
Professor, you're not sharing your screen.
Oh, I'm not sharing the screen. Sorry. Here you go. Now I'm sharing. Group number 4. Since you don't have any files there yet, right? You're going to see this, some generic picture. Can you see that now?
Yes, I can. Thank you.
Okay, good. And group number 4 will be, or your group number would be here at the top left. Let's go
Okay.
group number 5 now. And by the way, I'm testing those links before I send that to you. That's why I'm taking a little bit longer to do that. Just double checking to make sure. Group number 5 is Queen and Emily. Okay, so let's see. I'm going to stop sharing the screen. Group number Queen. Doesn't look like Queen is here, right? Queen and Emily. Yeah. Emily, share this link with Queen, okay, with your group member.
Okay.
And next, group number 6, Gabriela and Carlo. Good. Gabriela and Carlo. Gabriela. Carlo. Next, group number 7, Angelica and Princess. Okay, group 7 should have their link. Group number 8, Brandon and Jenny. Brandon and Jenny. Next, group number 9, Kimberly and Montserrat. Look like Montserrat is here, right? Or Kimberly.
I'm here, Professor.
Yeah, I'm trying. Oh, yeah, here you go.
I'm here also.
Oh, yeah, okay. So let me see. Let me send that to Montserrat first. For some reason, Kimberly's name didn't show up here. Let's see. Group number 9. Montserrat. Kimberly. Yeah, okay. Now showed up. Okay. Group number 9. Yep. Let's go for group number 10. Let me get this student here. Let's see why. Let's see, participants. What's going on here? Let me see what's going on here. Okay. Nobody's in the waiting room. Okay, admit. Now, Nicholas, group number 10. Nicholas. Okay. Okay, Nicholas, you should have your link right now. And next one is Jason. Group number 10 already also. Group number 11, Armon, Clef, and Arellano. Armon. Doesn't look like Taf is here, right? Oh no, Juan. Juan. And Sydney. Sydney. Sydney here. Armon. Okay, did you get the link, Armon? Did you get the link, Princess?
Yes, got the link.
Okay, so good. So we got everybody here. Is Sydney here? Let's see. I don't see Sydney in. Yeah, it looked like Sydney left. Oh no, Sydney is here. Did you get the link, Sydney? Let's see, I'll send that to you. Here you go. Good. Everybody should have the link. If you don't have a link for your group folder, let me know. Let me know now before we move forward. Now I can share the screen again.
Hi, Professor. This is Cecilia Chavez. I need the link.
Okay, what's your name?
Cecilia Chavez?
Which group number are you?
I'm not sure. I was running late, so I just got here.
Yeah. Let's see. Let's see. Is that type your name in the chat box because I didn't quite understand your name. Cecilia, right? Cecilia Chavez. Okay. Cecilia Chavez. Okay, you are group. Oh, you just came in. Okay, Cecilia, you just came in. Okay, in this case, I'm going to put you in group 12. Okay, for now you're going to be alone, okay? For now you're going to be alone. You might
Okay, thank
you might want to talk to Sydney. Okay, Sydney is group 11. See if she wants to join you. But for now, let's see, let me get that. And by the way, Cecilia, do you know anybody in the class that you'd like to be in your group?
No, not personally.
Okay, okay, good. So Cecilia. Okay, now you have your link, your group folder link. Okay, so anybody else who doesn't have a link, because before we move forward, you must all have a link to your group folder. And view data, sort, group number. So far, we have only 12 groups. There is a potential for how many groups? There's a potential for 17 groups. Okay, and we're gonna play with this link. Okay, click, Cecilia, you're group 12, okay? Cecilia, you're group 12. Click
Yes,
the
thank
link I sent you and make sure your group number shows at the top left of the screen. Okay. In the case of group 12, right? Here you go. Here is group 12. Group 12 is showing right in here. This folder is empty. That's why you are seeing something like that. Group 11, let's take a look. Group 11. Group 11 showing here at the top, and so on. Okay. Group 10. Group 10 showing up. Group 9. Okay, and so on. Group 8. And by the way, write down your group number, okay? You're going to need that for the rest of the semester. Next thing that we are going to do, we're going to do some exercises here. Make sure that you can download and upload folders, okay? Next, get any file in your computer, any file, any type of file, can be even a blank file, can be a doc file, can be a PDF, whatever you want. Any file on your computer. It can be any file. It can be any file. And write your name. Put your name as the title of the file. Okay. We have one student here that, let's see, who is this student? Okay, two students, Castaneda, and get any name in your computer You get any file, it can be any file, it can be PDF, doc, whatever, Excel, and put your name as the title of the file. Then you should drag and drop the file into your group folder. Okay? Let's do that. This is an exercise to make sure that you can modify the folder that make sure you can modify your group folder. Okay? I'm gonna do one here just to illustrate. It's not difficult. Let's see which one I want. I want let's see. Okay, let's use this. I'm gonna drag this file here to group. Let's see which group is going to be the lucky one. Okay, group 8. I'm gonna drag. Okay, someone already did that, right? Group 8. I want to see everybody doing that, not just one student in the group, but everybody. Who was that who dragged the file to the group folder? Was that Brandon or Janie?
That was me.
Okay.
Did not
Janie.
do that. Way
Okay,
to
just
go.
Janie, right? Okay, and Brandon, go ahead. Drag a file with your name too.
Yep.
No, notice that Janie put physics group number 8, right? I want you to put your name in the file. So let's see other groups here. Group 9, did you do that? No, group 9 still didn't do it. Let's see, group 2. Let's start with group 1. All you have to do is to click, drag, and drop. Okay, group 1 already did it. That's good. So that shows that your link is working. Eric and Edith, see that? Eric and Edith put the title of the file under their own name. So I'm going to insert drop file. Okay. Eric and Edith. Let's see group number 2 now. Group number 2 should be here. Group number 2, Jawaida managed to click, drag and drop. Now I need to see Arwa, okay? Arwa Paris. I need to see your file there, Arwa. Next is going to be group number 3. Group number 3 is the title is drawing 3, right? But I do not know which student was that. Group number 3 is either Ben or Melissa. Who is that? Who click, drag and drop the file?
It was Ben.
Ben, okay. So can you do that, Melissa? I just want to make sure everything works well on your side. That's good. Let's see here. Oh, okay. That's that's group 1. I don't want group 1. Group 4, group 5. Group 5. Queen. And now, Emily, I need you also to put your file in there. Okay, Emily? Let's go to group number 6. Only Gabriela dropped her file. I need Carlo to do the same thing that Gabriela did. Rename your file, click, drop, and click, drag, and drop. Next is group number 7. Upload. Okay, group number. Okay, here you go. Someone is a Kit Kat lover, right? Angelica managed to do that. Here you go. And the other student should be Princess, right? Princess, did you put your?
Yes, I was able to. It's the physics one. Sorry, you
Yeah.
can't see the whole name on there.
Okay. Your name is here, but it's been hidden. Okay.
Yeah.
Good, thank you. So both Angelica and Princess. Next, group number 8. Group number 8, that should be Janie, right? And Brandon still didn't manage to drop his file there, right? If you need any help, let me know, Brandon. Let's see, group number 9, Kimberly and Montserrat. Good. Group number 10, Cecilia, that's group number 12. Cecilia Chavez managed it. Another kitty cat, oh no, it's a dog. But such a kitty, a dog lover. Here you go. 12, let's see, 12, 11. 11 is Juan Torellano. So I need Juan Torres Arellano. Now I need the other students from group 11, Armon and Sydney, to drop their files in there. And let's see, group number 10, just Jason, right? Just Jason put his file. I need Nicholas to do the same thing that Jason did, okay? How many students did that, managed to do that? Okay, now Nicholas. Okay, looks like Nicholas put a car in there. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15. Queen, you're there, right, Queen Castaneda? Let me give you attendance for today's class. 24 students. So there's how many students didn't do that? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 students. Let's see. Let's review everybody here. Group 1, group 2. Okay, now we have both. Arad, okay, good. Arad managed to do that. Group 3. No, that's group 1. Group, well, where is group 3? I gotta get group 3 here. Okay, group 3. Ben and Melissa, right? So I presume that the other file is Melissa's. Next, group 4. Group 4, this one is Delisha. Okay, Madeline, did you manage to, Madeline from group 4 needs to add her file there. Group 5. Okay, now I have Queen and the other student should be Melissa, right? Group 6, Gabriela added her file. Carlo, I need you to add your file there too. And group 7, good. Group 8, Brandon, I need you to add your file there, okay? It looks like, let's see, group 11. I see if group 11 managed to upload the file. Yeah, just one student. I still need Armand and Sydney to upload the file. And group 12. Okay, 9, 10, 12 should be this one here. Yeah, should be this one here. Okay, so next thing that I want you to do, just delete the file. Delete the file that you have in there. So let's see. You can remove, okay, just click the 3 dots there and remove or delete. Make sure everything works well. Delete the file. So group 12 managed to delete it. Let's start from group number 1. That's group number 1. Let's see. Edith still didn't delete her file, but Eric did. Okay, Edith just deleted her file. Good. Jawaira, group number 2. Jawaira and Arwa. Okay, Arwa deleted. So it's working, right? Now it's Jaguara turn. Group number 3. That's group number 1. Okay, I'm gonna close this one. Group number 4. Group number 3. Let's see. Group number 3. Okay, 1, 2, 3. 1, 2, and 3. Okay. Both the students managed to delete the file. Let's see, group number 4. Delisha still need to delete her file. Okay. And group number 5 managed to delete both. Good. Group numbers 6.
Group 4 is deleted now, Professor.
Okay, thank you. Let's go there. Say 6, 5, 4. Okay. And group number 5, 6, 7. 7 deleted as well. Let's see 8. 8 deleted. Let's see 9. 9 deleted everything. That's good. 9, 10. Let's go 10. Okay, just one student deleted the file. Okay, one student, let's see. And 11. 11 deleted as well. Good. So it looks like it's working. Right? Some of you, for some reason, you couldn't upload and delete it. But if you have any problems, let me know. It's 11:50 right now. We can go for another break. Okay. Yeah. Links for the group folder. Notes. Okay, last, you may delete the file. Okay. So let's take a little break now. Break 11:50 a.m. to 12:05 p.m. And when we return, we will talk about the CL, okay? Or confidence level. So I see you in 15 minutes. We are back here, 12:06 right now. And we managed to do almost everything that I want. Okay, we did the groups. We divided the groups, right? Let's get my link here. We divide the class in groups. Okay, you tested your link your group folder link. It looks like it works, and it looks like it works, right? Looks like it works. Okay, now we are going to talk about a very important statistical parameter. Okay, so at this point in time, you should know some more statistical parameters already, right? The statistical parameters already. Okay, the first one that we learned whenever we were a little kid in elementary school is going to be the average. That's the first statistical parameter that we learn in elementary school, right? But then there are others. There is the standard deviation, which is a measure. What's the standard deviation? It's a measure of by how much a given parameter, a given set of data, a given set of numbers deviate from each other. Okay, it's a measure. That's what the standard deviation is. In case you do not know about the standard deviation, the equation for the standard deviation is the following. Most likely you know, right? The equation for the average is let me write the equation for the average that everybody should know. Here you go, average. Average is usually with X bar, right? Average of X. Average of X is what? Is the sum of every X from 1 to N, right? That's the equation for the average of X divided by N. That's the equation for the average of X. X bar is equal. What about the standard deviation? The standard deviation is a little bit more complicated. Okay, standard deviation we usually represent by the letter sigma. And remember, standard deviation is a measure of how much a given set of numbers deviate from each other. Okay, and how do we write that? It's still a summation. We still have a summation because we're talking about a set of data. A set of data, okay? Consider a set of data. Let's write that down here. Statistical parameters. Consider a set, a list of any mesh or n measurements, okay? And I'm going to x1, x2, x3, xn. Go, this one. Yeah. X3. Okay, xn. And those are all subscript. I'm not talking about, XY data. No, I'm talking about just a one-dimensional set of data, a one-dimensional set of data. Okay. Consider a list of one-dimensional set of data with n measurements. I'm not talking about XY, a set of XY. Okay, that's the average. The standard deviation is going to be what? It's going to be XI minus X average. x bar, okay, xi minus x bar divided by n minus 1. Okay? If every number is, if every xi are equal to each other, the standard deviation is going to be 0, right? There's no deviation from the mean, basically. If xi, if x1 is equal to x2, equal to x3, equal to xn, the standard deviation ends up being equal to 0. Okay? And you have learned about other statistical parameters. What else? Trend line equation. Trend line equation. This is another statistical beast, right? I told you about the R and R square values. And then there's another one that is important, which is related to R squared, which another very important statistical parameter that is related to R and R squared is the confidence level. Confidence level of a set of data points. Okay? Remember that I told you that, remember that I told you that R squared is a measure of how close your regression equation is to the set of data points in a graph. Remember that? Oh yeah, it is a measure, but it's not the ultimate measure. It is a measure indeed, but not the ultimate one. Okay, but not the ultimate one. The ultimate one is the confidence level that I call it CL. Okay. So the CL, I can write that down as being a function of both R and N, which is the number of data points. Okay, so here you go. The R square is a very good parameter to rely upon the correlation between the regression equation and your graph data points. The regression equation and your graph data points. However, this is not the ultimate one. This is not the ultimate one. It's not the ultimate one. Something else called the confidence level is a better judge for the regression equation. And the confidence level is a function of, I'm not going to put R squared. Oh, what happened here? I'm not going to put R squared. I'm going to put R. Okay, R and N. Is a function of R and N. It's a complicated function. For this reason, I'm not going to write this function right in here. Okay? The function of R and N. Not just R, but N as well. Okay? Depending on the number of data points for a given value of R, you will have different values of confidence level, different values for the CL. Okay, so what does it say? What does the above equation mean? What does the above equation mean, right? It means that for a given value of R, the CL will be different for two different values of n. Okay? That's what it means. Also, the higher the R is, comma, the higher the CL is. In another way, the higher the N is, the higher the CL is as well. Okay? That's how the CL relates to those two parameters. The higher they are, the higher the CL. The higher the N, the higher the CL as well. The higher the CL as well. We don't need is, we don't need is here, okay? And how do we find the CL? Well, we use a table provided in the course. This table is documented elsewhere, but not as detailed as the one that I have. And you may download this table from Canvas, okay? I want you all to download, please download this table. Please download this table. So you may all have that in your computer. You may all have it in your computer. Let's go to Canvas. LAC, Canvas. "23 students. Let's see, courses, section right in here. Confidence level right in here. Let me put here at the bottom. So the note, and this note I want to put at the top because the note for 2025. That's the one you want. Let's click on that and download to your computer, to the hard drive of your computer. Download confidence level. Right in here. I'm gonna open, is a PDF file. I generated this table using my own computer software. It's not easy to derive this thing. Like I said, it's a very complicated equation. And we do have simpler tables out there of this type out there, but not as detailed as this one that you have, okay? So let's learn how to read this table, okay? So first, you have to understand how this table is organized. Before you learn how to read this table, you must know how it is organized. And here's a very good way of summarizing this table. A very good way of summarizing this table. We have a row at the top. Actually, we have two rows at the top, but we need only one. And we have a column on the left side. Actually, again, we have two columns on the left side, but you need only one column. I should simplify this table, okay? See here, two rows at the top, alpha and CL, right? We need only this one. We need only the CL. I'm gonna simplify this table one day. And then we have two columns at the left side. Okay, the two columns are N, which is number of data points in your graph, and DF, which is degrees of freedom. For 3 data points, degrees of freedom is 1. 4 data points, degrees of freedom is 2, and so on, okay? N minus 2. And everything else that you have here is your R-square value. We call these R-square values, we call them the critical value of the correlation coefficient, of the determination coefficient. Okay, that's what this illustration is all about. Rows of CL, one row of CL, another column of number of data points, and the body of the table is the R square value. Okay. The CL is a value that's gonna be between 0 and 1. Okay, let's write it down. Just like the R square. Just like the R square, the CL assumes values between 0 and 1. In other words, between 0% and 100%. Okay? And that's the number that tells you how close your regression equation to your data points. A confidence level of 90%, confidence level of 99%, 98%. Or if there is no correlation, then the confidence level is going to be 0%. Okay? Anywhere between 0 and 100%. And now we can start playing with this table. Okay? Suppose, I'm going to give you an example. A simple example that does not happen in real life. It's very hard for this example to show up in real life, okay? But it's a simple example so you can understand how to use the table, okay? Example. Suppose you collected 6 pairs of data points, plotted them, 6 pairs, data points X and Y, plotted them in a graph, and obtained a R square equal to, let's put here, I'm gonna make up 1841255, okay? What is the CL? Plot them in a graph and obtained a regression equation. Obtained a regression equation with an R square equal to 0.841255. What is the CL? What is the confidence level? Okay, so I'm going to share this screen with my table right in here. Okay, they're going to be side by side. Okay, right here, let me zoom in. I want to zoom in even more. We're going to get the confidence level of this regression equation with respect to the set of data that we have. Example. So what did I do here? I highlighted n equal to 6, okay? 6 data points, 6 pairs of data points. And I'm looking for the R square value, 0.841255. See, here we have 0.658372, 0.841255. And as we move to the right, we get higher and higher values of R square, right? The critical values of R square. Coincidentally, not coincidentally, I did that on purpose, right? The R square value coincided with this critical value of R squared. And what does it tell me? It tells me that the confidence level of your regression equation is going to be given by this number here at the top, okay? 0.99, which is 99%. Okay? That's how you use this table. What you have here, alpha is just 1 minus CL, and vice versa. Okay? So this data solution, yeah? One, highlight the row where n equal to 6 appears. Okay, step by step, right? Find the value of 0.841255 along this line. Okay? And it is right here. Along this highlighted line, this highlighted row. Let's put, since I'm using row, let's use row as well. Okay. Then move upwards on the table until you intersect the row for the CL value. Read the value. Read the value is what? The value is equal to 0.99, which is equal to 99%. That's a better measure of the confidence level of your regression equation. Okay? Some instructors think that this 0.84 is 84%. Not so, okay? Because it's still dependent. There is still a dependence on the number of data points. We see what happens when you increase the n, the value of R squared goes down for the same CL, right? So it should, here is not 46%. If you have 13 data points, all you need is a R squared of 0.46721 to get a confidence level of 99%. Similarly, for n equal to 6, right? You need R squared, a larger R squared, to get the same confidence level. That's why I say that as the n increases for a given R value, as the n increases for a given R value, the CL increases. Okay, that's what this table is telling you. Any questions? You have? Yeah, go ahead, Kimberly.
So if our value is not in the chart provided in the PDF, we did something wrong?
The chart, yeah, it's provided, right? Let's take a look. Did you plot your graph?
No. I'm just asking, just in like future reference, like if our value
is not
listed in the CL chart, that we did something wrong.
Yeah, well, if you do not have the R square, you won't be able to find the CL. Okay, you must have the number of data points. You must have n and R square. If you do not have one of them, you won't be able to find CL. Okay, that's the answer to your question.
All right, thank you.
But every graph, you are going to have the number of data points and the value for the R square. Kimberly, you want to ask a question too?
Yes.
Yeah. Go ahead.
That was my question.
Ah, that was your question. Okay, I thought you was. I
Thank
thought
you.
you had another question. Okay, thank you.
No. Thank you.
Your hand was still raised here in my Zoom. Okay. Okay, so now we can start playing with this table using this graph here. Okay. And now you have to just keep in mind you will in real life you will never get R square value that coincides with those critical values. In real life, you don't get it. You're not going to get them. You're going to get a number that falls in between them, right? That's what you're going to get in real life, in actual real life. Okay? And we are going to do that for this case, okay? For this case that we have. Let's take a look. R squared is 0.9924, okay? Another example. N equal to 6 R squared equal to 0.9964. No, 9924. Okay. Find the range of CL values where your actual CL lies, okay? I didn't ask you to find the exact CL. Look what I write it down there. Look what I wrote down there. I asked you to find the range of CL values where your actual CL lies, okay? So you do the same thing, solution. Highlight, it's going to be slightly different from this procedure here that I outlined, okay? And you're going to see why. Highlight the row where n equal to 6 appear, right? So here you go. Here's my row. And it's, let me zoom out. Hopefully you can see it. Here's my n equal to 6. Okay. Find where your R square lies within this table. Okay, so one more. Yeah, here we go. N equal to 6. Right in here. 0.9924. 0.9924 is between what? Is between this value and this value. See that? Right? 0.9924 at n equal to 6 is between those two values. 0.9924 is greater than 0.98, less than 0.994. It's closer to 0.994 than to 0.98. What does it mean? It means that my CL is going to lie between those two values here. 1 minus 10 to minus 4 and 1 minus 10 to minus 5. Okay? Find where 0.9924 lies in the table. Okay? It's going to be in the, which column is this going to be? 1, 2, 3, 4, between the columns 4th and 5th. Okay? Between columns 4 and 5th for the R square. Okay? move upwards, just like we did on the table, until you intersect the row of CL values. Read the value, and the value that we get, read the value. Your CL, your actual CL value lies, I do not know exactly what the value is, but I know the range that is where it's located, between 0.9999, okay, 99.99%, and 0.99999, 99.999%. That's where the CL is located. Okay? Did you get the idea how we use this table? We will be using this table for the rest of the semester. I call this value here the lower bound of CL and the upper bound of CL. $12.38. Any questions? Does everybody, I just want to make sure that everybody has been assigned to a group. Is there any student here who doesn't have a group, who hasn't been assigned to a group? 21 students. We assigned a group to 24 students. Okay. Let's do another example. Now we are going to go back to that outlier example, right? Let's go back to that outlier example. Let's say 10. R square went down big time, right? We still have 1, 2, 3, 4, 5, 6. So what we're going to do now, there's another way of playing this game. There's another way of playing this game, okay? Example 3. 5, 6 more minutes to go. Hopefully we can finish before. Another way, another example, another way to play this game using the outlier we talked before, right? So n equal to 6, r squared with the outlier is going to be 0.8378, right? With the outlier. We're going to compare, let's see, what are we going to do? Compare, right? The CL, of your plot using the outlier. No, let's put it this way. Obtain the CL of your plot using the outlier. Then repeat, okay, with the outlier, n is equal to 6, right? Then repeat by excluding the outlier, n equal to 5, okay? With the outlier, the r square is going to be what? 8378. 8378. Without the outlier, n equal to 5. The outlier is the r square is going to be what? I'm going to take away the outlier here, and I'm going to find out what the r square is. Okay, the r square now is 0.9901. Let me make clear. Okay, 0.9901. For n equal to 5, 0.9901. Compare the two CLs. That's what Compare the two CLs. Compare the two CLs. 12:42, you have 8 more minutes to go. So it's twice the work, right? You have to do the work twice here. I'm gonna move sideways. Oh yeah, here you go. Solution, highlight the row for n equal to 6. N equal to 6. Make sure you get n equal to 6, not df, the degrees of freedom equal to 6, right? And look for r squared equal to 0.83. R squared for equal to 0.83. Okay. For n equal to 6, your CL lies between 95% and 99%. Uh, 99%. Okay. For n equal to 6. Right in here, right? Here's the range. Your 0.83 lies between those two. And your CL is going to be between those two values. 95% and 99%. Now you repeat for n equal to 5. Oh. For n equal to, oh, what the heck's going on here? Go. For n equal to 5, 12:44, 6 more minutes to go. Okay, we have that r squared is 9901. N equal to 5, 9901. Oh, do you see what happened here? When we eliminate the outlier, we get a higher value for the CL. Okay? For n equal to 5, we go 9901. 9901 is between those two values. We get a CL between 99% and 99.9%. Okay? 1 minus 10 to minus 3, and 1 minus 10 to minus 4. So you are better off using your data points without the outlier. Okay? You're better off eliminating your outlier to get a result. I do that because sometimes that's not always true, okay? Sometimes when you eliminate the outlier, you end up with a CL that's less than the previous value. 12:45. Let me erase that here. So that's the type of problem that we're going to do in the lab. Here you go, that's my third example. That's my second example. That's my first example. Okay, with all the steps. Any question? I covered everything that I wanted. And let's take a look at the syllabus. 4 more minutes to go before we stop. Let's see. Excel graph, group assignment. Okay, we didn't do 1D motion, right? We didn't do 1D motion, but we did CL, confidence level. So let me update here. 1D motion number 2, 1D motion number 3. Okay. Make sure you keep your link in a safe place. Huh? make sure you keep your link in a safe place for the rest of the semester, right? And don't forget your group number. And don't forget your group number. There is no homework due whatsoever, but if you want to prepare yourself for the next meeting, you can look at my notes of 2024, which are posted there in the internet. Okay, here you go. Here are the notes of a year ago. Okay, here you go. Data points, real life. Regression equations of mathematics. Yeah, that's an important thing to put there, right in my notes. Keep that in mind. My data points is a reflection of real life, whereas my regression equation is a mathematical model of the real life. And the mathematical model can be either good or a bad one. Okay, so let's put that. I think it's a very nice way of describing. Remember, data points is real life. Regression equation is just a mathematical model of your real life. And examples that I did a year ago. Remember, don't share the link of your group folder with anyone outside the members of your group, of your lab group. Okay, and then what we're going to do next, we are going to look at the equations of motion. Okay, we did that already. This one we did last time. Let's see. Okay, definition. Okay, we're going to look at graphs x versus t. That's what we're going to do. X versus t, v versus t, and so on. Okay, and then we are going to look at the equations of motion for uniform motion and accelerated motion. Here you go. Here one of the graphs. So that if you wanna take a look before you come to class, that's where you should look at on the 9th of September 2024. Okay, 12:49. We can stop here. Just 1 minute to go. If you do not have any questions, I'll see you next week. Next week, yeah, next Monday. Okay. Thank you for
Thank you,
being here.
Professor.
Welcome.
Thank you, Professor. Have a nice day.
Professor, have a good day.
You too.
Professor, I have a question.
Yeah. Go ahead.
So you said that there was no homework, but there is homework on the Wiley plus,
Oh,
right?
yeah. That's right. There's homework for the Wiley. Yeah, that's right.
Okay. And
No
then
homework
my
other than the one assigned in the Wiley Plus.
right.
Okay.
And then I guess I'm a little confused for lab. So this is what we're doing. This is considered the lab, what we did today.
This is an introduction to the lab. Okay, you have to know this stuff before we start the lab. And when we start the lab next Wednesday, you will need to use all this information that I lectured today.
Okay.
That's
Okay.
the whole idea.
And then, okay, so there's nothing we need to do as far as using Excel as of right now until
No.
for this.
Yeah,
Okay.
there is no homework for the lab, right? That's what I mean. There's no lab report due. Okay.
Got it. Okay. All right. Thank you.
Okay.
Have a great day.
You too. Okay. Wait, pode? Okay.
No.